All right. So oftentimes we have mixtures of gases. We rarely have just, one gas. And you think that make things really complicated, but because our gas molecules don't actually interact with each other, it's really not that much more complicated in terms of a mixture of gas versus a pure gas, in terms of the pressure, volume, temperature, that kind of thing. So the total pressure of a mixture is just the sum of the partial pressures. So for example, air is a mixture of nitrogen, oxygen, argon, carbon dioxide, and then a bunch of other things that are in very small proportion. And so the total pressure, P total, is going to be the sum of its parts. So PA plus PB plus PC and so on and so forth, right? Where A, B, and C are just different types of gases. So the pressure of our air is going to be equal to the pressure of the nitrogen plus the pressure of the oxygen plus the pressure of the argon plus the pressure of the carbon dioxide. And each one of these components is called a partial pressure because they only make one component of the total. They are only a part of the pressure, right? In order to get the total pressure, you have to add them up. In terms of air, the values are, it's mostly nitrogen, 0.78 atmospheres. After that, oxygen is not too far behind at 0.21 atmospheres. That's the part that our body actually needs to live. Argon, not very much, 0.009 atmospheres. And then carbon dioxide, 0.0004 atmospheres. Also not too much, but as you may know, that number is increasing, which is not a great thing. And so then if you think about what the pressures of the air is, you just sum them all up. So it's a 0.09994. We only have 2 sig figs, so it adds up to 1 atmosphere, which is what we would expect. Again, very simple, just that the total pressure is the sum of its parts. Let's take a look at an example problem. So a mixture of helium, argon, and neon has a total pressure of 0.734 atmospheres. The partial pressure of helium is 112 torr, and argon is 341 millimeters of mercury. What is the partial pressure of neon in atmospheres? Well, actually, let's do torr. In torr. I'm going to use all of our units. And so again, this is a plug and chug type of problem. We first need to indicate the overall reaction. We can see that we're given partial pressures. We're talking about a total pressure. So our equation is going to be that the pressure of the total is the sum of its parts. So in this case, the pressure of the total is equal to the pressure of the helium plus the pressure of the argon plus the pressure of the neon. In this case, we're given the total pressure as 0.734 atmospheres. So that would go into there. We're given the partial pressure of helium as 112 torrs. So that would go there. And then we're given the pressure of argon as 341 millimeters of mercury. So that would go there. And then you can see that what we want is our partial pressure of neon. So that's the part of the equation that we want. So we want to isolate that part of the equation. And so to isolate that, we would subtract the partial pressure of helium and argon from both sides. And then your new equation would be the partial pressure of neon is equal to the total pressure minus the pressure of helium minus the pressure of argon. And then the last thing we want to think about is we want the answer to be in torr. So we want all of our units to be in torrs. So we need to convert all of our units to torr. Let's start off with the 0.734 atmospheres. For every 1 atmospheres, there's 760 torr. So we get 557.84 torr. That 7 being the sig fig. And then for helium, right, we need to, or my bad, for the argon, that's in mercury, millimeters of mercury, we need to change that to torr. So 341 millimeters of mercury. And for every 1 millimeter mercury, you have 1 torr. So it's the same number, 341 torr, right? So cool. Got everything in torr. Now we can just go ahead and plug and chug. So the total pressure is going to be 557.84 torr. The helium part is going to be then minus helium up here, 112 torr. And then finally, minus the amount of argon, which is going to be 341 torr. Now just chug through, do the math. You get 105 torr as your partial pressure of the neon. So again, not too difficult of a problem. Plug and chug type of thing. Identify what equation you need. Plug the numbers in with doing any conversions that you may have to do in the intermediate steps, and then chug through and solve algebraically. Note that you do need to, organize your work, right? When you read this work, it's pretty obvious what I did. You don't have to use the exact same format as I do, but you do need to make it very obvious of what you did. If you just have random numbers with no units all over the place, it's not a good way to communicate.